This video introduces us to the basics of viewing windows on the TI-83, TI-84 calculators. In the first example, we're told that we have the graph of the linear equation y equals 0.005x minus 50. We're given a graph and asked what viewing window is being used in this graph. In order to figure this out, we're going to go ahead and label a couple points on this graph. I know how to find the y-intercept of this graph and the x-intercept of this graph. I'll go ahead and identify those points, label them on the graph, and that will help us identify the viewing window. First, I'll find the y-intercept. The y-intercept occurs where the x value is 0. So on this graph, if x equals 0, I plug in x equals 0 and we get y equals negative 50. So the y-intercept is the point 0, negative 50. On the graph, that is this point here, the point on the graph where the graph crosses the vertical axis. I'll go ahead and label that. Now that I've labeled that, I can go ahead and also label these tick marks. I notice that this y-intercept seems to occur right on one of those tick marks. So if that is a tick mark, and this, and this, and this, and all tick marks are equally spaced, we must have that this tick mark would be negative 25, this is negative 50, here's negative 75, and negative 100. The x-axis occurs at 0, so that if going up the other direction, we have 25, 50, 75, 100. So right now I can actually label the y-min, y-max, and y-scale. Y-min on the viewing window is the lowest y value we see on the window, which is negative 100. Y-max is the highest y value we see on the window, which is positive 100. Y-scale is the distance between each tick mark, and we see on this window the distance between each tick mark is 25. Now I need to do the same for the x-axis. I'll go ahead and find the x-intercept using the equation. The x-intercept occurs where the y value is 0. So I let y equals 0 in my equation, and I solve the equation for x. Adding 50 to both sides, I now have 50 equals 0.005x. Divide both sides by 0.005. And when you take 50 divided by 0.005, we get 10,000. So the x-intercept is 10,000, 0. Now I can go ahead and label that point on the graph. The x-intercept occurs here where the graph crosses the x-axis. That is the point 10,000, 0. Again, I see that this graph hit the x-axis right at that tick mark. That tick mark is 10,000. This tick mark then must be 5,000. So 5,000, 10,000, here's 15,000, 20,000. The y-axis occurs when x is 0, and then going backwards, this must be negative 5,000, negative 10,000. Now I have enough information to tell us the x-min, x-max, and x-scale. X-min is the lowest x value we see on the graph, which is negative 10,000. X-max is the highest x value we see on the graph, which is 20,000. And x-scale is the distance between each tick mark on the x-axis, which is 5,000. So now we have found the viewing window we would need to use on the calculator to get this graph. Let's do a similar exercise. This time we have the equation y equals negative 300x plus 15. Again, we'll find the y-intercept. It occurs where x equals 0 and we find that y equals 15. So the y-intercept is 0, 15. That's this point here. Finding the x-intercept. The x-intercept occurs where the y value is 0. I let y equal 0 and solve the equation for x. When we let y equal 0, we found x to be 0.05, so the x-intercept is the point, 0.05, 0. And I'll go ahead and label that on the graph. Now that I've labeled these 2 points on the graph, I can go ahead and label each of these tick marks. This is 0.05. This would be twice that distance, so adding another 0.05 would be 0.1. Adding another 0.05, this would be 0.15. This is 0, and going backwards 0.05, this would be negative 0.05. If this is 15, it looks like this would be 5, 10, 15, 20. Here's 0, and going backwards, this would be negative 5. So the x min is negative 0.05. The x max is 0.15. The distance between the tick marks, the x scale, is 0.05. The y min is negative 5. The y max is 20. And the y scale is 5. And there's our viewing window for that equation.